Okay, hello, my name is Ikra Ansari and I'm from group number 324. Today's our topic is the conformational properties of enzyme. So in this we will going to study about the physics must be concerned with the quantitative aspect of this picture, indicating at the same time to what extent the effect listed. In conclusion, we shall consider the data that characterize the rate of the enzyme and the analogous non-enzyme processes. So we will going to make a table in which we will going to see the each and every component of the enzyme and its property and the rate and the rate of non-enzyme part. So first we will have lysozyme, and second we have chymotrypsin, and third we have fumarase. So one by one we will going to see the properties of this, like it has the rate of 5 multiplied by 10 raised to minus 1, and it has the rate of 4 multiplied by 10 raised to minus 2. It has 5 multiplied by 10 raised to 2. The non-enzymatic part has 3 into 10 raised to minus 9, and it has 1 into 10 raised to minus 5, and it has 3 into 10 raised to minus 9. So this is the data in which the rate of the non-enzymatic and the enzymatic part are multiplied. So we will going to see and understand the enzymatic activity. It is necessary to consider the conformational behavior of the protein macromolecule. As we know, protein is made up of the amino acid, so it is known as the macromolecule. The conformational liability of the protein make possible its interaction with substrate and other ligand. In some conformation, the protein bind the substrate more efficiently. Simultaneously, there take place a selection of the conformation of the substrate. The conformations of the protein and the substrate that are selected into the enzyme substrate complex are those which are structurally complementary to each other. Like if we need to make the enzyme substrate complex, there must be a structurally complementary to each other. They should be like same in their structure. They should not be in a different structure and properties, thus providing the optimal value of the free energy of the interaction during the formation of the enzyme substrate complex. The conformation of the protein and the substrate fit together. The conformation changes involved lead to the structural fit between the enzyme and the substrate. The conformational effect determines the significant changes in entropy during the formation of an enzyme substrate complex. A decrease in the entropy that occurs during the fitting interaction can be compensated for by decrease in enthalpy. So a physical analysis of the event of this kind required that phenomena that occur in the water environment be taken into account. At the turn of the century, the Fisher proposed the lock and key model. So what did he propose? He proposed lock and key model for the enzyme and the substrate complex. So he proposed this model. Let us understand this. For the treatment of the enzyme-substrate interaction, the enzyme and the substrate possess the rigid structure. First of all, they should have the rigid structure. First is they should have rigid structure. The active side of the enzyme being structurally complementary to the substrate so that it fit with the substrate in much the same manner as the key fit in a lock. Like the key, when it fit into the lock properly, it should be the same phenomena when the enzyme and the substrate are interacting with each other. Okay, and the number of the fact contradict this model. The enzyme substrate interaction is probably not static one. There should be non-static one. Okay, but is rather a dynamic interaction. The Koshland advanced and induced fit theory to account for the specificity of the enzyme-substrate interaction. Let us recall the basic postulate of this theory, which was designed primarily in an attempt to explain the specificity of the enzyme that are catalyzed bond transfer reaction, is given as this, like that P plus XY, it is the reversible reaction, B Y plus X. The substrate caused change in the geometry of the enzyme as it fit into the active site. A delicate orientation, yes, the orientation is most important. The orientation is required for the enzyme action. The substrate induce the proper orientation. Of course, the induced fit theory covers also those cases which involve the alternation of the conformation of the substrate rather than the enzyme conformation of food. The main idea of the theory is determinative role of the conformation liability interacting molecule of the enzyme catalysis. So why did we study these? We study for the enzymatic catalysis. To have the enzyme on its most effective state, we need all that properties to be equally fulfilled. Thank you.